Bobby McCumber and welcome to VU Open Day. Today's panel we're going to be discussing science and information technology, and I have three panellists who will be joining me. First off, we have Dr. Tom Yeager. He's an academic and the former chair of Bachelor of Science course for many years. Thank you, Tom.
Thank you for having us.
Next up, I have Dr. Asefa Teshome, who is a lecturer for information technology. Thank you, Asefa.
Thanks for having me.
And lastly, we have Dr. Kandaka Ahmed. Dr. Kandaka is an academic for information technology. Thank you.
Thank you. Thank you for inviting me.
We'll start off with you, Kandaka. Let's address the industry broadly. Can you tell us a little about the IT industry and how it's evolving?
Well, so IT, the discipline, naturally IT is evolving from the beginning. 15 years before when I did my bachelor, what I have learned is completely changed or changed a lot. So in IT discipline, we tell our students or we tell our academics or the people that you have to keep on always learning. So the same thing is happening now as well. And we can see the automation is happening faster than ever. However, this COVID is even making this, the pace increased, this remote learning, distance learning, Zoom, these things would happen anyway, but this would probably happen in 10 years' time, but due to COVID, it is happening in, 1 to 2 years' time or in few months even. Now, with another thing that is happening is, artificial intelligence, machine learning, that we used to hear for 15 years, for a decade or more than a decade. I still remember 12 years before I used to teach a subject called artificial intelligence. But in that space, nothing that much was happening, unless over the last 3-4 years. So over the last 3-4 years, what is happening, some big corporate, for example, Google, Microsoft, they started bringing different tools and making it in a way that, in sort of application level programming. So the use of artificial intelligence, the use of different data analytics tool is increased a lot. And therefore, the decision things are made pretty much data-driven. However, one thing is common is the programming skill in IT. So no matter the formation is changing, different things are coming, people are talking about cybersecurity because a lot of things we are putting in the cyber space, and therefore securing that space is very important. But whatever we are doing, one thing is common, which is the programming skill and being able to adapt and learn the new things and apply it and solve it.
Given that the industry is evolving so rapidly, can you tell us about some of the majors and minors that the students go
Definitely.
through in IT?
So just before I tell what are the courses we have, I just would like to give one insight. VU does have a fantastic data insight team as well, who looks at what are the different jobs available. So the top 3, they are top tier jobs, and IT definitely standing in 2 or 3 right after health professionals. And within the IT, also programmer or developer is I think the highest. The next one is not even 50% of programmer or developer. So you can understand the demand for programmer or developer is very, very high. Whether you go for cybersecurity, whether you go for AI, whether you go for data analysis, you still need to know the programming language. Keeping that in mind, in our Bachelor of IT, we call the course, undergrad course is Bachelor of Information Technology, and it has 2 majors. One major is mobile application development. So basically this major is more focused on teaching software development, programming, how to develop web application or desktop applications. The other major is network and system computing. Not necessarily everybody likes programming. Somebody probably likes more networking stuff. So for them, network and system computing major is there. So that's in undergrad. We have also Bachelor of IT Professional. Within that, there is a 1-year industry placement opportunity. So a student do a full-time 1-year industry placement. And in our postgraduate course, we have a Masters of IT and Graduate Cert of Cybersecurity. But our key focus or major focus is to work on data analysis, AI, some cutting-edge technologies, use the sensor technology so that students always familiar with the cutting-edge technologies and new technique and be ready for the industry.
Our courses here at VU within IT actually rank quite high within the industry, which demonstrates, I guess, the quality of courses that we have here. Can you tell us a little bit about those rankings?
So ranking, basically, when the ranking happens, one of the focus of the ranking or the dominating field factor is, research. And IT discipline in Victoria University is very, very strong in research. It has a long history. So we have a pool of academics. We have a pool of academics who do both teaching and research. And we have also a pool of academics who are only do research. The whole entire pool is doing fantastic job. And based on that, based on the research outcome, based on the teaching that we are doing, our students are going into industry. According to Times Higher Education, computer science of VU is second in Victoria and 8th in Australia. So it's really, really putting a very strong impact in terms of computer science field itself.
Thank you, Kandakar. Sefa, I'll go to you now. If students don't get into the course that they're initially trying to get into and they want to enter via an alternate entry point, can you tell us about some of the pathways and options that they have?
Yes, I think that's a good question. And we have a number of opportunities for our students to come in, and not necessarily everyone needs to have a science or IT background to jump into IT. Those that have a direct science background can qualify, can jump into the IT directly as first-year students. But also for others with a different background, as you know, IT is highly interlinked with the business world, and interlinked with even some social science fields as well. So if students with different background wants to join, then the special application that they need to fill in, that will be assessed at the discipline level before the entry is made, and that's how we proceed. And another thing I would like to add together with that is we are now on the verge of launching our new course, another IT course, which is Bachelor of Cybersecurity. So for that, we have also an interesting pathway opportunity, especially for those Cert 4 cybersecurity students who have finished their bachelor of their certificate in cybersecurity. We have designed the course in such a way that they can, most of what they have done can be equivalent to their first year work, and a chance for them to join in with most of the units they have done credited.
So they've got lots of options there, which
Yeah,
is great.
lots of options.
Yeah. Getting into the finer details, can you tell us specifically what type of jobs students can gain after studying here IT?
Well, I think that's what makes the discipline of IT very exciting, because as Kandakar mentioned, IT is really growing at a rapid way, and especially when you look at machine learning, data science, cybersecurity. Particularly, I'm more excited talking about cybersecurity and artificial intelligence. And as you know, cybersecurity is one of the major priorities the Commonwealth government is, the Australian government is putting a big focus on, with roughly around $1.3 billion allocated to grow the sector. So there is a huge demand of IT professionals as cybersecurity experts, IT professionals as software developments. There's huge everywhere. Everything we do in business relates to some form of web-based application or mobile application. So IT graduates can find their way in the software development industry and the data science and machine learning industry as well. Yeah.
Sounds like there's plenty of jobs out there in IT, especially in cybersecurity nowadays. Yeah. Thank you very much for that, Sefa. We're going to cross very soon to Emily Bodie, who is in one of the science labs here at Victoria University, Footscray Park. Before we do that, when we return, we will be talking all things science, and we will also have one of our students studying a Bachelor of Science, Stella, who will be coming in. She'll be chatting with us. First of all, leaving us, I'd just like to say a big thank you to Kandakar for joining us as well. We'll be back very soon. Over to you, Emily.
Hi, Bobby. Thanks so much. I'm coming to you from Victoria University Science Laboratories at our Footscray Park campus. It's a real hive of activity. There's a lot of people working on a lot of things. So come with me. I'm going to interrupt them and see what they're working on. Chattery, this looks interesting. Tell me about what you're doing.
Hi, I'm in the middle of running a gel actually. This is a very important technique that our students get to learn in their, our environmental students in their final year. So this is something very important because they get to look for specific genetic markers in DNA by running this gel electrophoresis.
Why is it so important that students are able to do this?
Because of you can separate different DNA, different markers, RNA proteins in one of the in a mixture, so you can separate them according to their size after running this.
Awesome. And environmental science, so important in this day and age as well.
It is, yes.
We've also got plenty of chemistry units on offer, so I'm going to scooch over here and have a chat to Larry about what he's working on. Hey, Larry, tell me a bit about what you've got going on.
Yes, this is our atomic absorption spectrometer. We use this for our second and third year practical chemistry classes, mainly for looking at metals in samples. And it's an Australian invention, actually. Back there, it's been 70 years since it was first produced. And basically, it's a very widely used instrument, mostly in pharmaceutical, environmental analysis, and for mining industries.
Amazing. Well, I know we don't have long, but there's one more thing I really want to show you guys, so come with me. Here in our science laboratories, we have an FTIR machine. We've got it all set up so we can find out a bit more about what it does. Hi, how are you?
Thanks, good.
Give us some information about our FTIR.
This is another sort of a spectrophotometer using the organic chemistry. We basically use IR radiation to analyze the sample. It's a modern technique used in most of the organic people doing organic chemistry.
Yep.
So especially in Victoria University, we're using second, third, and research students to identify and fingerprint the raw material or the finished product of an organic compound.
So when you say IR, what kind of technology is that, or what kind of process is that?
IR is a sort of a light. It's in the it's a part of a light spectrum. So we use the IR radiation to use on this machine.
Awesome. Thank you so much for spending some
Thanks.
time with me and explaining this
Thank you.
awesome machine. That's just about all we've got time for, so it's back to you in the studio, Bobby.
Thank you, Emily. Now, Tom, looks like we've got some state-of-the-art equipment here at VU in that lab. One of the things that stood out for me was the work that was being done with environmental science. Can you tell us a little bit about the work that was being done in the lab and also what students can expect to learn?
So some of the work that's being done in the lab is studying different samples and trying to figure out if there are compounds that are of interest that we're looking at that might be too high or in the environment, so we can see if there's pollutants or things that we can study and try and figure out maybe try and trace them back to where they've come from. But we have a lot of cutting edge technology that we're able to use, and the students don't just learn it, by the book. They actually get to do hands-on work, which is fantastic for real-world applications.
Now, Stella, thank you for joining us. You've snuck in there. You're studying Bachelor of Science here at VU in your second year.
Yeah, that's correct.
Tell us what a day in the life of a VU student is for you.
Well, because science is quite heavy content, we have pre-reading classes which actually allow us to help when we go into class and allow us to understand what we'll be learning during that day. And then after that, depending on the subject we're studying, we may have lab or we may not. So if we do have lab, we would be pre-reading the lab reports that we need to complete and then going into lab and completing the lab reports, completing the studies that we need to do.
Thank you, Stella. Tom, great to hear some of Stella's experiences. Can you tell us about some of the majors and minors that students will be studying?
So in science, there's two majors. There's the biotechnology major and the ecology and environmental management major. And then we have the chemistry minor, the maths minor, and some other combinations of biotechnology and ecology that have kind of mixed and matched. And it gives the students a nice broad ability to do a number of things. So you could take two majors or a major and two minors. So it gives you some flexibility on what you want to do and what you want to study to kind of tweak or tailor your science degree to what you're looking for your outcomes.
Given that science can be quite broad, like you've mentioned, what are some of the job prospects for students that are studying a Bachelor of Science?
So if you're coming out in the biotechnology field, you can do things, everything from working in medical research. So I used to work at CSL, and I hired a number of students from VU to work at CSL doing working in cell cultures, doing the influenza virus growth and things like that. Also, you can work at do forensic studies. You can work at places like the National Measurements Institute, where we've had a number of students have become get jobs there after doing placements. And in the ecology end of things, you look more like looking at local councils doing land care, brush care. You can work with the groups doing fire regeneration. So there's a lot of very interesting and exciting possibilities that you can get from coming out with a science degree.
It's a common theme across each of the degrees that the work placements, it's a foot in the door to so many different industries, and students are aware that they've got these opportunities when they're coming here at VU, which is fantastic.
Yeah.
Now, we've got some questions that have been given to us from students that are interested in studying either science or information technology. So I'll throw these out to you guys and see how we go with them. Tom, we'll start with you. This question is, will the course give me the skills I need to be competitive when applying for a job in science?
Yeah, so one of the things that we've noticed and the government's noticed is that a number of people or a number of companies are looking for science students, and they don't find science students that have the qualifications and the skill set they've learned that they need. They get the book learning, but they don't get the other 21st century skills that are necessary to work and adapt and really flourish in the science end of things. Where we, like with Stella doing her her works, we get you in to do teamwork. We get problem-based learning. We do a lot of hands-on, not just rote learning things. We basically have different challenges to put with you, and you work as a team in a lot of cases, and try and figure out with the background knowledge you have how to try and answer things, which is more like what's going to happen in the real world, where you don't just have a test and that's how your job works. You actually you have a problem that you have to solve it and work as a team. And we get a lot of good teamwork and a lot of good, problem thinking and skill-based things, and a lot of hands-on, activities as well. So if you go into the lab, you learn how to do different techniques. And then one of the good examples is, in the second year, they have one of the chemistry classes. You're given basically a white powder, and you say, here's the lab. We'll teach you how to use these, whatever you need to do, but you need to figure out how they work and what you're going to do from it. And so it's a good, problem-based learning, and you work with your other students, and everyone gets to, work together as a team to figure out what they need to do, how they need to do it, and it really helps them down the track of, being an independent learner and an independent thinker.
Following on from that question, I'll throw to you, Stella. Do you believe that VU has helped you to develop these competitive skills?
I definitely agree with that, especially with having the VU block model. It helps a lot in my studying. So with year 12, you had to juggle all these subjects all at once, but with VU block model, I'm able to focus on a specific unit or subject at once. So if I'm doing biology, it will be biology for the 4 weeks, and then I'll be able to advocate all my time and effort into just understanding biology in one, and then moving on to the next one instead of trying to juggle all these subjects in one. So VU has definitely helped, especially creating that VU block model.
VU block model seems to be very popular with the students and the teachers that we've spoken to on different panels here. I've got another one here for you, Tom. What are some specialist laboratory skills that students get to learn in our science degrees?
So in the biotechnology end of things, you'll learn everything from PCR and learning how to do some DNA sequencing. In the chemistry labs, you'll learn what they were talking about, the infrared IR technology, learning NMR, learning a lot of different good chemicals, maybe atomic absorption, spectra work. And then in the ecology end of things, you'll look at doing microscope work, looking at plants, trying to figure out maybe doing how to do sampling and do camera trapping and things like that. So a lot of very applicable skills that you can take to your future job and be confident that you're ready to go and going to be helping and hitting the ground running, instead of starting a new job and then you're like, oh, I don't know how to do this and do that, and you have a lot more confidence, a lot more good, good skills that are applicable, and you're going to be a very valuable person to start right from day one.
Stella, how have you gone honing your skills in the lab? Have you been in there, and what are some of the things that you've enjoyed doing?
Yeah, been from first year, and even now we're still inside the labs. It has been a little crazy, but able to understand how some of these, I'm just trying to think of the technologies used. So like, say if we're going to learn about gel electrophoresis, we're able to learn and understand how that works. And with the sample gels, understanding what's going to be used and how we can create data and write a lab report on those stuff.
Great, thank you, Stella. Thanks, guys. I might throw to you, Asefa. So information technology based this question. What are some of the postgraduate courses that are available for students?
We have two postgraduate courses that are available for our students. One is the Master of Applied IT, and the other one is graduate certificate in cybersecurity. So in Master of Applied IT, what they will need to do is advanced courses, which are really again equipped with applied concepts and foundations that will engage students in that will equip the students in becoming the new the students that meet the criteria the industry demands in programming, in machine learning, artificial intelligence, and again with a strong emphasis on cybersecurity.
Got another question for you for information technology. So we'll stick with you, Asefa. What are the placement and Capstone project opportunities in information technology?
There are exciting opportunities with regards to Capstone and placement opportunities. As it happens, I'm also the Capstone coordinator for the discipline of IT. In Capstone projects, we have a dedicated lab set up for IT students, wherein after all the years of study they have in IT, we give them the opportunity in applied projects where they could create from start to finish a complete applied project in IoT, in communicating with IoT devices, in machine learning with audio chatbots, facial image recognition, and all those cool and interesting stuffs that are happening in these days. And on top of that, we also have this opportunity. For example, I have a couple of students who are directly working with an industry project. They are working for the industry basically, but they are doing that as part of their IT. We at VU IT also, IT discipline also proud ourselves with how we try to reach to the community. So we try to develop several projects with small and medium enterprises, like other governmental offices like Maribyrnong City Council with our Smart City project. And we try to place our students in those projects wherein they can, at the same time, contribute to the success of the project, at the same time, learn from those projects as part of their Capstone project. Yeah.
Great, thank you, Asefa. We'll finish with one final question, and I'll throw this one at you, Tom. I hear that there is a degree pathway of the Bachelors of Science with Masters of Teaching. Can you explain how this works?
So when you apply to your bachelor's degree, you apply to this dual degree, and when you get into the dual degree, so you do first year 3 years of the Bachelor's of Science, and if you have the minimum standard, you're automatically accepted into the Master's of Teaching, and that's a 2-year degree. So then you can go through your 5 years without having to worry about reapplying for going into your Master's, and you can go straight from the undergrad in the Bachelor's of Science into the Master's of Teaching. So that will give you the teaching qualification plus the scientific background to be able to do a very strong job doing teaching science, which is great. So it's nice having that 3 years of science background. So you've got a really strong science background. So when you're going in to teach VCE, you should be able to have at least chemistry, maybe do chemistry, biotechnology or biology, maybe even maths, and ecology. So you had a number of different specializations that you can use in your teaching degree once you graduate. So then you take your 2 years doing your teaching degree, and learning how to deliver your science to the students in a much stronger, much more effective manner that way. So it's a great opportunity if you want to do the teaching to get it in a very compact area.
Thank you, Tom. And thank you very much, Asefa, and also Stella and Kandakar, who was with us earlier as well. So thanks for watching. I hope you guys have got a good insight into not only the science, but the information technology departments here. We've got some state-of-the-art facilities with our science lab here at Footscray Park, and plenty of jobs going in cybersecurity as well for IT. Thanks very much for tuning in, and we wish you all the best in your future studies at VU.